Welcome Pure Maths 3 students to week 3 of our maintenance program. Hope you've had a chance during the week to do some practice and also complete the exercises here. We're looking at algebra and logarithmic and exponential functions again today. A bit of a review from what we looked at earlier. So the first one, we've got this modulus inequality. So as mentioned in previous weeks, I'm just going to square the modulus. I'm going to square both sides, in fact. And then in the next line, I will expand that out. So I get negative 6, negative 12x plus 4 should be less than or equal to 16. I'm going to bring that 16 across. And what do I get there? That's negative 12 less than or equal to 0. I could make that 3x squared minus 4x minus 4 is less than or equal to 0. And then, oh, I'm running out of room. I'll come up here. So what could we do here? I think, I think it's going to be like this. We'll factorize it. X there. We'll have minus 2 and then a plus 2 here is less than or equal to 0. Actually, that's really unfortunate. It's a bit messy. I hope you can see that. This is 0 there. Okay, so that gives us, now I'm going to do a quick sketch. Well, we've got a point here. That's that one. All right. And then this one here is at negative 2/3. So here. I have not drawn that correctly, but you get the general gist. Having trouble with my equipment. Okay, there we go. And we want is less than or equal to 0, so it's between those values there. So I would say for this one, my final answer that I would give would be negative 2/3 is less than or equal to x is less than or equal to 2. I think that should be the correct answer there. Now, moving on to this next one here. I square both sides, and then I'm going to square this here. So I get x squared is greater than 9x squared minus 6x minus 12x minus 12x plus 4. Bring everything across to the right hand side, so I get 8x squared minus 12x plus 4. I'm going to divide everything out by 4. So I'm going to get 2x squared minus 3x plus 1. Now, that was less than 0. 0 was greater than that, so this will be less than 0. Okay, I've just rearranged it. Okay, now can we factorize this? Yes, we can. I think it's going to be like this. 2x minus 1. X minus 1 is less than 0. Let's just quickly check that. 2x squared, yes, minus 2, minus, yeah, perfect. Okay, right, so we'll do our quick sketch. Okay, so we've got 1 at 1/2, and we've got 1 at 1. So there we go. It's looking like that. That's 1/2. It's 1. And we want is less than 0, so it's between those. So my final answer here would be 1/2 is less than x is less than 1. Okie dokie, moving on to the next one, we're going to square both sides. I'm just going to jump in and do that quickly. X squared plus 6x plus 9 is less than or equal to x squared minus 8x plus 16. Okay, bring everything across to the left side. So we get 14x actually. And I won't bring it all over there. I'll bring the 9 across to the right hand side, which gives me, subtracting 9, so it will give me 7, and I'll get x is less than or equal to 7 over 14, which is 1/2. And that would be the answer there. X is less than or equal to 1/2. Okay, the next one is sketch y is equal to the modulus of x plus 3. Okay. Whoops. Okay. So we know that it crosses the x-axis at minus 3. because minus 3 plus 3 is 0. That's the only place it can be 0. And then every time you go across 1, so here's 2, minus 1, 0, you go up 1, because the gradient of the x here is 1. Okay, 2, 3, 4. So 3, no, that should be about there, shouldn't it really? So we'd be here, and we'd be here, and we'd be there. So it's going to cross the y-axis at 3. Sorry. So to go, oh man, goodness, go like that. And then as we go across, it's going to have this gradient like this, going like that. So that would be the graph of y is equal to the modulus of x plus 3. Rough sketch. Okay, let's move on. Okie dokie. So given the fact that fx is equal to x cubed minus 4x, use the factor theorem to find the factors and fully factorize. Okay, so well, okay, all right. So I'm just gonna, you can actually just do this in your head, but what we'll get used to doing is using the mode setting on our calculator. We can use the table mode. We can stick in the x, the function which is x cubed minus 4x, and then we can start at minus 5 and we go to 5 and we step up in integers, step up in 1, and then we're looking for anywhere where we have a root, and I can see that there's a root at minus 2, so f minus 2 equals 0. So that means therefore that x plus 2 is a factor, and we've got f 0 equals 0. So we've got x as a factor there. Then we've got f 2 is equal to 0. Therefore, x minus 2 is a factor. And that's it. Okay. So what we've got here is x into x plus 2 into x minus 2. Sorry, I forgot to write x is a factor. Right, and we've fully factorized it using the factor theorem. Right, so which is when you put in a number, or an input a number, and you get a 0 out, that means that the factor is x minus whatever you put in would be a factor. Okay, now we can solve the equation. Well, x equals 0 or minus 2 or 2. We found that out in the previous question, and we can sketch the equation of the curve. So here's our y-axis. We've got a point here at minus 2, a crossing point here at 2, and one here at 0. We've just got to look at the shape. We can tell that from the input that we did into our calculators. Starts off very negative, and then it comes down and around here and out like that. Okay, so that is the sketch of our curve. Perfect. Moving on to the second section, which is logarithmic and exponential functions. And we've got to express the following in terms of log x. Well, another way of writing this log square root x is log x to the power of 1/2, and therefore 1/2 log x is what we're looking for there. The next one we could rewrite as 3/2 log x plus, and this is log, whoops, that's a bit dodgy, log x to the power of 1/3, and we can rewrite that as 3/2 log x plus 1/3 log x, and then we just go, all right, 3 over 2, and then subtract 1 over 3, which is 7/6. So we could go 7/6 log x. Okie dokie. Moving on, we've got to solve this equation. and find x in terms of a, where a is greater than 0 and a does not equal 100. Okay, alright. Okay, so what I think we want to do is we'll just go log a of x equals log 2x plus 1. Okay, now we can use our, so I'm taking a log of both sides, it's log blah equals log blah. Okay, right, now you can go log x log a equals 2x plus 1 log 10. And then we can expand, so I think it's x log a equals 2x log 10 plus log 10. Now we bring the minus x log a minus 2x log 10 equals log 10. I'm going to factorize out the x's. So I'm going to get x into log a minus 2 log 10 equals log 10. Hopefully you're following my logic so far. I'm running out of room. I'm going to go up here. So I'm going to go x, and then I've got that log a minus, I can write log 100 equals log 10, and then I can write x equals log 10 divided by log a minus log 100, which is like log a over 100, isn't it? Using our log rules, because they're same base. That's an a, but it doesn't look like an a, does it? So I better just adjust that accordingly. Alright. And I think that's all that we need to do for that one. Okay, the last one, we've got to solve this equation, giving our answer correct to 3 significant figures. Okay, for this next one, what I'm going to do is I am going to bring the 5 to the power of x across to the side. No, I'm not. This is what I'm going to do. I'm going to leave the 5 to the power of x here. I'm going to pull the 5 to the power of x minus 1 across to the same side, and I'll pull this over. So I'll pull this over here and pull this over here. Okay? That's what I'm doing. Now, another way of writing this is 5 to the power of x minus 5 to the power of x times 5 to the power of minus 1 equals 5. You might be thinking, well, wait a second, how is he getting that? How is this equal to this? So we can just like think about it like this. Let's say I had 2 to the power of 4 minus 1, okay? That is equal to 2 to the power of 4 times 4 1 is 5. making log a